Okay, so we have these two reactions here, and they want us to draw the potential energy diagram for both of these reactions on the same graph. So let's say we have energy here, and then we have time. So they tell us that the first reaction is exothermic and the second reaction is endothermic. And they also tell us that the activation energy, so the EA of the exothermic, so reaction 1 is greater than the activation energy of the endothermic reaction. So let's sketch the first reaction first, right? So it's an exothermic reaction, right? Let's just say we start at this energy right here, and then we go all the way up because of the activation energy. And since this is an exothermic reaction, that means the energy of the product should be lower than the reactant, right? So then we draw the curve to a lower point than the reactant. Now for the next one, we have an endothermic reaction. So let's say we start here, the activation energy goes up. Now I'm drawing the activation energy a lot smaller because the question tells us that the activation energy of this reaction is larger, right? So we can't have a larger activation energy in 2. And then this is a endothermic, it means that it ends up with at a higher energy level than the beginning, right? So we have the activation energy here. This is the activation energy. And then this is the activation energy of the second one. We see that the second one is a lot smaller, like the question told us. And we see that in this one, the reactant has a higher energy compared to the product, meaning it's exothermic. And we see that in this one, the reactant is at a lower energy level compared to the product, which means it's endothermic.